I space out. I space out a lot. I like working that.
Okay.
All that's taken.
Alright, so the first step of this is that when we do the sum of the forces, I'm going to do a force diagram for right here. Hey guys, get work done, please. I'm going to do the force diagram for right where these three strings like come together. And so if I do that, I'm going to have this one going up in that way. I'll call it, what do you want to call it? 1, 2,
FT1.
FT1. And then I'll make this one FT2. And then I've got gravitational force going down. I'm just going to pretend like that box is at the dot. It just makes things easier. Okay. So if I do the X and Y directions for this, I can break this into components. And I can break this one into components. Does that make sense? Okay. And so then I'm going to redraw it.
I just went like this, you know? You should do it again, Milo. Ready for a trick shot?
You're number one.
Bang.
I should do that. Milo's number one.
I'll call you friendly.
Okay. Does that make sense? Don't worry about how long they are. I just wanted to make sure that that FT2Y and FT1Y were not the same length.
Yeah.
Because they're at different angles. I don't know, like, I could think about which one's actually bigger, but right now I don't care. I just want to make sure that they're not the same.
Why would you?
And then I have gravitational force going down. And so what I want to notice is that in the X direction, these are going to have to be the same. Because otherwise I'm going to have acceleration in the X direction.
Got it.
Which is going to be a problem. So, if I do the sum of my forces in the X direction, I have FT1X minus FT2X, and that's going to have to equal 0, because it's not accelerating side to side.
Okay. Yeah.
So then I can say, oh, that means FT1X is going to be equal to FT2X. Okay. Now, it wants us to do up to this number for your hypotenuse. So it says that this FT1 can be up to 1,500 pounds. FT2 can also be up to 1,500 pounds. So as long as it's 1,500 or less, it's not going to break. If it's more than 1,500, we have problems. What I'm going to do now is I want to think about, okay, so if I'm going to draw something at a 45-degree angle, like I'm going to just draw this FT1 first. If I draw it at a 45-degree angle, and I have this much in the X direction, I'm going to end up with the same amount in the Y.
Yeah.
Okay, so this is T1. Now, if instead I draw this and have the 30-degree one, like in the same amount. Let me do it this way. So like I start here, and I need to go the same amount, but to the left. And this angle, so this one was 45 degrees. This one needs to be 30 degrees, which means it's smaller. Do you see how this force is smaller now
Yeah.
than that one?
Okay.
Okay, so that means FT1Y is bigger than FT2Y.
Mary, what problem is this?
7. Chapter 6 homework, or chapter 5 homework number 7. Are you good with that?
Yes.
Okay.
So how do you decide like which one's gonna be 1,500? Would it be FT1?
So this one is going to need, like, if this part is the same for both of them, this one's going to be bigger in the Y direction, And the hypotenuse then is bigger for this one.
Oh, okay. So it has
Does
to
that
be
make
FT.
sense?
Yeah.
Because if the horizontal part's the same and the
Oh, I
angle's
see.
bigger, the height's bigger, so then your hypotenuse is bigger.
Yeah.
So what I'm gonna say is that means that this one, because this is gonna save us a lot of work later, is we're gonna say that this one is the 1500 Newton one.
Because that's the bigger hypotenuse.
Hmm.
Yeah.
Which is weird because,
Because if this one was 1500, then this one would be more than 1500.
right,
and that's
exactly.
right. Okay, got
Yeah,
it.
and then that one would break. Yeah. Okay, so what we can do is we can now figure out FT2x.
Oh, so it'd be 1500 sine 45, or
Mhm.
cosine 45 equals x, or some variable.
Yeah, cosine of 45. And we can plug that into a calculator.
Equals, like, variable cosine of 30? Or 60?
Oh, I guess I should write it over here, huh? Because, oops. Because that's FT1x.
Oh,
Right? And then that needs to be equal, that happens to be equal to FT2x.
which is,
So we could figure out this number. And then if we were gonna try to figure out, like we can use this, and it's gonna be a little bit awkward, but because of these triangles, we can then figure out our FT1y and our FT2y.
okay. Oh, wait, I'm writing. And then you divide it by sine of 30?
Just tell me what this first part is.
Oh, wait, no, because cosine 30.
Yeah, because that's what's pulling on this, pulling on
Or
this
just a
to the left.
paper.
Yeah, just give me the first part for
Pulling on
now.
this to the left. And then this FG is what's pulling on it to the right. Not nine, but it's
1060.66.
So it's just, you could, I guess, if you wanted to do.
You wanna join us? We're doing number 7.
On this?
No, on the bookwork. Okay. So we figured out what the x direction is of each of these. So once we have the x direction, now we can find the y direction.
Oh, because they're just equal.
Because, right, so this is 1500, and we figured out that the x direction was 1060.66. So then FT1y, we can figure out. This is 45 degrees. And then we can do the same thing for the 30-degree angle this way.
Oh, but it's gonna be different because if you do M1 plus.
And then this is 1060.66 for the x direction on that one as well. And then this is FT2y, and you have the angle. Okay, so the easiest is going to be to use tangent, because you have two sides. So tangent of 30 degrees is equal to opposite, which is FT2y over adjacent, 1060.66. So what's 1060.66 times tangent of 30?
I don't know why she put it there, because then
If it's the whole
well,
system,
then
then
the
it has a
cases would be the same thing. It, both,
Okay,
each case.
so now we have the y of that. And then if this is 45 degrees, these two sides are necessarily the same. So this should also be 1060.66. All right, so we're going to go back to this force diagram. And I'm going to do the sum of my forces in the y direction. So then I'm gonna have ft2y plus ft1y
This is just being
minus
told.
fg
I think
equals
the
0.
difference is that it's a weight, so it's acceleration.
You get,
Plus the force is in that direction.
okay, so you did,
Are you recording this?
mhm.
Is it gonna be on Google Classroom?
Yeah, I might redo it if I have time, but if not, I'm gonna just try to have at least something, even if it's a bad recording.
Okay.
And I don't know how well it's gonna turn out because I haven't done it. Like sometimes the audio from the iPad's weird. So I have to use my computer when I record myself. Okay, and so you get 1673.03. And that's FG. Okay, but it asks mass. How do we find mass?
Divided by gravity.
Okay, so then we have to do, so that's equal to mg. So we divide it by 9.8.
is more mass in the tax.
170.7.
Because they're attached. Make it make sense.
That makes a lot more sense. The book gave this like really weird solution where you end up getting like
Yeah, but one has
10,
weight.